This is going to be the second video in the glass and paint unit of forensic science, and in this one we're going to look at identifying glass evidence. So one of the most important properties we're going to look at to determine if the sample of what we've got is actually glass and not something like plastic or some other shiny material is the refractive index. So beyond examining the fractures, the refractive index is the primary method for comparison. Glass is what is called isotropic, which means it only has one refractive index. Other substances will be anisotropic, which means they have more than one refractive index. Refraction is a change in speed and direction of a wave as it enters a new medium. And in this case, we're talking about light. Light will bend and change speed when it moves from air into glass or from air into water or what have you. And so the refractive index is a comparison between how light refracts in a vacuum and how it refracts through an object. And the refraction is governed by Snell's law, which is a relationship between the path the light ray takes in one medium and then the path of that same light ray in a new medium. And it says that the refractive index of the first medium multiplied by the sine of the angle of incidence, which is the angle that the light is hitting the boundary, equals the refractive index of the second medium multiplied by that angle of refraction. So here it is mathematically. So N1 is the first refractive index, and then sine theta 1 is the angle of incidence that the light ray makes with the horizontal. And then N2 is the second refractive index, and sine theta 2 is the angle that the light takes when it exits into the new medium. So when finding the refractive index, the first thing you're going to see is it isotropic? So is it glass? And what you'll do is underneath the microscope, you'll use a polarizing filter, which is a filter that goes in between the light source and the sample that will make the light only go in one direction. And the polarizing filter can determine if the unknown sample is glass before you do anything else with it. So what happens is when you put these filters in place, then the glass will disappear. Other materials like beryl, which looks a lot like glass, will show what's called birefringence, which is what this picture is. It's kind of an oily sheen under double polarization. So if you see birefringence when you engage the double polarization filters, then what you have is not glass. You can also use fluorescent microscopy to determine if it's glass. The filmed glass, like laminated glass, will glow under a fluorescent filter that you can put. And so next time we're going to talk about how we use refractive indexes of glass.